You may not be done with these yet, but let's go ahead and take a look and see how you're doing. Number one here is just a simple rectangle. So the area for a rectangle is just length times width. Doesn't matter which measurement we use for the length and which one for the width. We typically think of the length as being longer than the width, but it doesn't matter. So this is 3 feet times 16 feet. Well, 3 times 16 is 48, and feet times feet is square feet. So it's 48 square feet, or 48 feet squared. Number two, the area of a circle is pi times radius squared. Well, here we have the diameter, not the radius. So the first thing we have to find is the radius, which is half the diameter, excuse me, which will be 8 inches. So this is pi times 8 inches squared. Or if you're using 3.14 for pi, it'd be about 200.96 square inches. If you use the pi key, it'd be like 201.08 or something like that. Number three, triangle. Remember, the area for a triangle is related to that related rectangle. So you can think of it as length times width divided by 2, or base times height divided by 2, or 1/2 times length times width, however you want to look at it. So this one we have our 12 inches by 29 inches divided by 2, which gives us, what was that, 174 inches squared, square inches. And finally, number 4. This is a trapezoid. In a trapezoid, remember, we have two bases. The bases are the sides that are parallel. Short one we're going to call little b, the long one we're going to call big B. The area of a trapezoid is the average of the bases. You add them together and divide by 2, and then times the height. The height is the distance between bases. So for this one, we have 7 plus 17 over 2 times the height of 10. 7 plus 17 is 24. 24 over 2 is 12. 12 times 10 is 120. Those units are in feet, so that is square feet. Any questions on any of those 4? Yes, sir.
So I did it as there are two different triangles. That's how I
You could have done that as well. Yep.
got the same answer that way.
Yep, it would have come out exactly the same. That works on this one because this height happens to come right at the corners. If it didn't work out that way, it would have been a little different. But yes, that worked because of that height being exactly there. A trapezoid, actually, I'm glad you brought that up, because a trapezoid can, if you know the dimensions, be broken down into triangles and rectangles if necessary. Let's say that if this is 8 inches here going up, and we'll call this piece here 6 inches. Call this up here 12. And this piece we'll call 27. Again, assuming those are right angles there. We can, if we know those dimensions, and we do here, break this down into 2 triangles and a rectangle. Now, realistically, we need to know this dimension and this dimension. Well, we know this one here is the 12 inches. This one over here has to then be 15 inches. So now that can be broken down into a rectangle and two triangles, into three shapes. So the first shape, that rectangle, is 8 inches by 12 inches, or 12 by 8, however you want to look at it, which is 96 square inches. The second shape over here is a right triangle that is 15 inches by 8 inches, divided by 2 because it's a triangle, so that's 60 square inches. And the third shape here is also a right triangle. That's 8 inches by 6 inches, and again, divided by 2 because it's a triangle. 24 square inches. That all adds up to 180 square inches. Or we could have used the trapezoid formula, which would have been base plus base. This would be 33 all the way across down here, divided by 2, and times that height of 8. 12 plus 33 is 45. 45 divided by 2 is 22.5, or 22.5. Times 8 is 180 square inches. The trapezoid formula will always work. Breaking it down into three pieces like this only works if we're given the dimensions down here on bottom broken up properly, so we know how big the triangles are and how big the rectangle itself is. Which kind of brings us to our topic for today. But before I do that, does anybody have any questions out of the homework? Okay, so just a reminder, there is a quiz out there from Friday that was due yesterday, but it's still out there. Only a couple people turned it in, so make sure you get that finished. And there are a few of you that still need to do that. There's also going to be a new quiz today. It's posted out there in September 22nd. It'll be due by noon tomorrow, September 23rd. So most of you are going to have a couple of quizzes out there that need to be done and submitted. The first one hopefully submitted sometime today, the second one by noon tomorrow. Well, let's take a look at some strategies for finding areas of these shapes that are not just rectangles, triangles, trapezoids, or circles. We'll start out relatively simple. Something that looks like this. So here, let's say that this is 17 inches, 25 inches. Let's go 32 inches here and 22 inches up here. Assume all of those corners are right angles. I'm not going to go mark them all with little squares in the corners. There are two methods that we could use to find the area here. The first method, which I'm going to call method 1, is to cut it apart and add the pieces together, add the areas together. Well, what do I mean by that? Well, this can be cut in a couple of different ways to create just rectangles. I could cut it across here and have 1, 2 rectangles. Or I could cut it down here and have 1, 2 rectangles. Either way, it'll be about the same amount of work. Since this is what I have drawn right now, let's leave it just like this. So rectangle 1, that area is pretty easy to find. That's 25 by 22. "25 inches by 22 inches is 550 square inches. My second shape here is a little bit more work. I know this is 17 inches. I don't know this dimension here. How big is that dimension in green going to be? What's the size of it?
10.
10 inches. Very good. Because the 22 and the 32 are the only other dimensions that go horizontally. Those are the only ones I can use to find that missing dimension. And the 22 plus that missing dimension has to add up to 32, making that one 10. So that'll be 17 inches times 10 inches is 170 inches squared. That adds up to 720 square inches. That's the first method. Method 2 is to fill in missing pieces and then subtract them back out. Let me show you what I mean by that. Well, that would look like this. We fill in this corner to make it a big rectangle. We know that big rectangle is 25 inches by 32 inches, otherwise known as 800 square inches. But then there's a little rectangle in the corner here that we had to fill in that's actually missing. We have to subtract it back out. Well, we know this is 10 inches here. We need to know this dimension. What's that dimension?
8.
8 inches. Very good. The 25 and the 17 are the only other vertical dimensions, so we combine those to get that 8 inch. So that piece that's missing is 8 inches by 10 inches, or 80 square inches. We subtract, we have 720 inches squared. Now in a shape like this, it's about the same amount of work either way. To cut it into pieces, add them together, or fill in the missing spots and subtract it back out later. There are some pieces, however, that are going to be considerably easier one way or the other. Like this one. Again, we're going to assume that all corners here are right angles. This one isn't horrible to cut up into little pieces and add back together. We could cut it like this, and we'd have 3 pieces to add together. That first rectangle is 20 by 8, 20 inches by 8 inches, or 160 square inches. Second rectangle requires us to know this dimension right here. What's that going to be? (20 minus 8 leaves us with 12 inches there, correct? So that's going to be 12 inches by 14 inches, 168 square inches. Then finally, the third piece down there, we know this is 20 inches from the top because this is 8 inches. It goes back to the same size by 20 inches, 400 inches squared. So that all adds up to 728 square inches is our final area. However, this is one that I would argue is probably easier if we do the whole thing. If I do the whole big thing out here, I do have to add up the 8, the 14, and the 20. Get 42 inches is that long side there. But now I have that whole area is 42 inches times 20 inches, or 840 square inches. And then I'm subtracting back out this 8 by 14 rectangle over here, which ends up being, what, 112 inches squared? We subtract, that gives us 728 square inches. So filling in that piece and subtracting it back out made that a little bit simpler, one step fewer to finding that area. Again, probably not a huge deal. I'm going to have you guys try a couple in your notes. Let's do them. Again, assume all those are square corners, even though they're a little off. Find that one and this one. Let's take a look and see how you're doing so far here. I know some of you are not totally done. Number one is one I think is definitely easier to cut into smaller pieces and add them together. So I just have it cut straight across like that. Piece one is 6 inches by, got to find this dimension up here. Well, I know that this here is 12 inches, which means this is 12 inches, plus 15 makes that 27 inches across there. So that's 6 inches by 27 inches, which makes that, what, 162 inches squared. Piece two is 12 inches by 10 inches, making that 120 inches squared. And piece three is 18 inches by 20 inches, making that 360 inches squared. Adding up to a grand total of 642 square inches. How many of you had that? Good deal. Any questions on how we got to it? Okay. Number two, I would say, is one that's definitely easier to fill in the missing pieces and then subtract. To do that, we have to know these overall dimensions. Well, this one down here is just 8 plus 14 plus 4, which is 26 inches. This one here is 4 plus 12 plus 6, which is 22 inches. So to get that large area, it's 26 inches times 22 inches, or 572 inches squared. Now we have to subtract out this little piece, which is 4 by 10. It's 40 square inches. This little piece, which is 4 by 6, 24 square inches, and this piece here, which is 8 by 2, or 16 square inches. So that adds up to a total of 80 square inches that needs to be subtracted, bringing us to 492 square inches of area for that piece. That one, if we'd have tried to cut it up into smaller rectangles, because nothing lines up, and I did that on purpose, you would have had a ton of small rectangles, well, 4 of them, but you had a lot of weird dimensions to find those areas. It would have been a lot more work to try to do that. Well, we can throw in circles and parts of circles. We already done a problem like this, finding the circumference or the perimeter of a half circle. But what if I give you that this is 10 feet and I want to find the area of that? Well, we're just going to treat it like it's a full circle. First of all, we would have to have the radius, which would be 5 feet, half the diameter. So the area of the full circle would be pi times 5 squared, 78.5 square feet. So then the area of our half circle is going to be just half that. Divide that by 2 is going to be 39.25 square feet. And for right now, we're going to stick to known fractions of a circle, half circles and quarter circles. Later on, we will get into other smaller sections of the circle and how to find those areas. But we can combine this with our other shapes. A little bit better than that. Let's say we have a rectangle here with a half circle embedded on the end of it. We're going to call that 20 inches, and we'll call this here 8 inches. To find this area, I'm going to chop this off, and we have two areas. Area 1 is just the rectangle, 20 inches by 8 inches. It's 160 square inches. Area 2 is just a half circle. Now the diameter of that half circle is 8 inches. We know that. So the radius is going to be 4 inches. So that'd be pi times 4 squared. And we're going to divide it by 2 because it is only half a circle. That gives us 24.5, not 24.56, 24.12 square inches. We add that up to get 184.12 square inches. I'm going to put these two side by side so that you can see the contrast. This is a rectangle, but rather than having a half circle added to it, it has a half circle cut out of the end of it. So we're still going to do this one. We're going to find that large area. 20 inches by 8 inches is 160 square inches. This circle, or half circle, still has a diameter of 8 inches, which means the radius is still 4 inches. So its area is still pi times 4 squared divided by 2, which is still 24.12 square inches. But now, since it's missing, it's cut out, it has to be subtracted, giving us 135.88 square inches of total area. Let's talk a little bit about a cylinder. Since we're combining circles and rectangles, a cylinder is a perfect application of combining circles and rectangles. I'm actually going to jump ahead a couple of weeks to a concept we will study a lot more in surface area. Talking about the surface area of a cylinder. Pretty sure I butchered the spelling there. I have no idea if I spelled that even close to correctly. Yeah, cylinder, C-Y-L-I-N-D-E-R, that's correct. Okay, so cylinder. Let's say we have a diameter of our circle here of 10 inches, height of our cylinder of 20 inches. The surface of this is made up of 3 shapes. 2 of them are the same, the circles on top and bottom. So the area of that is just pi times radius. Now the radius is going to be half of that 10 inches. It's going to be 5 inches. So pi times 5 squared. 78.5 square inches. Then, of course, another 78.5 square inches on top. It's what we call the lateral area We'll describe why that's called lateral area more when we get to surface area directly. But the area between the two circles that we have to worry about. Well, we can think of this piece of paper here rolled up as being a cylinder. A circle on each end, if you use your imagination a little bit. My circles aren't perfect. But we can cut down the side of that cylinder and unroll the piece of paper, and what we have for those surface that edges is just a big rectangle. The height of this rectangle is still just the height of that cylinder. The length of the rectangle is the distance around the circle, or the perimeter, the circumference of that circle. So to find that rectangle, we first find the circumference of that circle, which is pi times 10. Remember, it's pi times diameter. That's 31.4 inches. So the area of that rectangle is 31.4 inches times that height of 20 inches, giving us 628 square inches. Adding that to those two gives us, what is that, 157. So 785 square inches of surface area. So we can piece together known shapes to make surface areas as well. Because a circle has a consistent radius, the radius of a circle or a section of a circle is the same no matter what direction we go. If this is a 5-inch radius, that's a 5-inch radius, and that's a 5-inch radius. That's a 5-inch radius. That radius is 5 inches no matter what direction we go inside that circle. We can use that in our shapes. If I have a piece of a circle, well, there's a quarter circle. And if I tell you that this here, usually we mark the center of the circle like that so you know that's a portion of a circle. If I tell you that this down here is 20 inches, and this here is 28 inches, and let's call this over here, let's just go with 20 inches again. I can find this dimension here now. The reason I can find it is because that circle, or portion of a circle, has to have the same radius in every direction. This distance from the center to here is the difference between the 20 and the 28. That's 8 inches. Well, if the radius is 8 inches in that direction, it has to be 8 inches here as well. So now I can use that to find that this has to be 12 inches. Those have to add up to the 20 inches total. So now I can find the area of that shape. We have the large rectangle that is 28 inches by 20. Giving us 560 square inches. And then we're going to subtract out this quarter circle. That's pi times 8 squared would be the full circle, divided by 4 because it's only a fourth of a circle. And what does that end up being? 50.24, I believe, square inches. We subtract that out. To give us an area of 509.76 square inches. So the circles, because of their consistency and dimensions, are a very, very useful tool when finding missing dimensions and areas. Homework today is going to come out of the big book. Pages 682 through 685. Exercise 27-2. Problems 1 through 30. Actually, probably 7 through 35 actually on this one. Find those missing areas, find the areas, find missing dimensions and all that. Also remember there are 2 quizzes out there. There's the quiz from Friday and then the one from today. That need to be completed. Now, if you're looking on Blackboard in the course information section, there's a packet that is posted for September 23rd. That packet contains homework that we are going to use over the next couple of weeks. I would recommend, it's probably easiest if you can do it, to just leave the packet on your computer screen and do the homework in a notebook separate to it, just because it'll save on paper. And there's a lot of pages in that packet that you don't necessarily need. If you are going to print it, stop at page, for now at least, stop at page 177. This is a packet that I use for all the sections of this course. Page 177 is the end of the area portion of that packet. There will be some surface area and volume stuff that comes up that we will need later. I'll repost the packet if I have to. And then the very end of the packet, like I said, I use that packet for all of my sections of this course. 2 of the sections of this course deal with woods constructions. So at the very end of that packet, there's stuff on measuring board feet and lumber pricing and stuff like that, which you guys obviously won't need for CNC. So if you do decide you want to print it off, for right now, don't go past page 177 of that packet. Okay, so you guys have plenty to do here. I've only left you about 7 minutes left. So if you want to get started on your homework, I'll stick around on the network to help you out if you have any questions. Otherwise, if you want to get rolling, you are welcome to go.